Yeah, so with that, we'll go into section 3. Certificates killed the radius stars. To some degree, there's some truth in that. Some of it's just humorous. But I'll show you kind of why we refer to that and why we refer to radius as being a protocol, not a server. You know, this is all about building on scalable, sustainable networks through what we deem as automated device enablement as being our area. And so at the end of the day, through device enablement. Just some real basics, so I don't lose you on terminology and whatnot. So the top one's Peep with MSChap v2, or same thing applies for TTLS with PAP and so forth. The bottom one's certificate-based. So the top one's really password-based, the bottom one's certificate-based. Sometimes we'll see confusion on customer-based where they say, we ask them, what are you using today for WPA2 Enterprise? And like, well, we have a certificate. And you have to really dig into it to figure out that what they're really talking about is this certificate. So just for clarification, whatever type of secure EAP method you're using today, you're going to have a server certificate. And the purpose of that is that's the server's identity. So that is what the server initially is going to send to the client. So the client can look at it and say, do I really want to send my username and password to this Radius server? And so there's different mechanisms within server-cert validation for how it does it, but at the end of the day, it's going to do a comparison against hopefully a known list. In reality, sometimes now it's just, hey user, do you want this thumbprint? And user will click accept. The difference comes in that on this device, we have a cached password. So users typed in their password at some time, it's gone on the file system. Depending on the OS, it varies as to how well it's protected. Most of the time, it's protected pretty well, but there's issues like the Android thing. There's also cases where some products will, particularly on Linux, they'll just throw it in the text file, and you'll end up with clear text password. But we want that password's going to go back to the server, and that's how the server is going to decide who this user is and what level of access do I want to give them. When we get in the certificate environment, the key piece of information to remember is that when you're in certificates, there's two components to it. And so in password realm, this predates public key, private key encryption. And so you had one key, just like a shared secret on your Radius server, that both sides had to know about. And you had to transport them across, because that was the only way you could prove that you had the same key. And if you're using TTLS PAP, that was literally a clear text password going through the tunnel. If you're doing MSChap v2 as a NTLM hash, which so it's just a very weak hash. But at the end of the day, there's something about the user going through the information, even if it had been a very secure, encrypted mechanism other than MSChap v2. At the same time, we still would be transporting information about that password. With certificates, we have a private key, which in an ideal world never is anywhere other than this device. And we have the public key, which we can just publish on a website if we want, because it's not useful. So the device is always going to hold its private key. It's always going to transmit its public key to the other side. And then it's going to use encryption using the private key to transmit data. And the other side will use that public key to decrypt its information. And so that certificate becomes the identity. The key thing is it's not handing over all of its credentials. It's only handing over the public portion. So if we look at kind of the scope of wireless support in Peep, this kind of goes back to the previous section where we talked about the coupling of Wi-Fi issues with password issues. And from the beginning, we would transport a password over to the user, which goes into their head. At some point, they're prompted for that password. Now they got to translate that from their head into their fingers. In the old days with laptops, that was generally fine, and there's known issues there. Just people typos, whatnot, made more challenging with mobile keyboards and whatnot, complex passwords, long passwords, all that sort of thing. But then that password comes across. We got to get it to the Radius or the AP. And the AP has got to get it back to the Radius server. The Radius server has got to get it back to AD. Because there's absolutely no way he can just determine any sort of trust until he knows yes or no binary is that password good? So if any of this fails, it's a failed authentication. To the user, it looks the same. Now in a TLS world, it's very different. So in a TLS world, we can separate password issues from Wi-Fi issues, right? So this top part almost looks like the old captive portal. It's the same behavior when a user goes through a reset password website, all that sort of thing, or just using their password on a website in general, right? We give the user their initial password. They still got to translate it, but when they do, they're sending it back to a web server, protected with HTTPS. Just like a web application, if the password's wrong, we can provide them special information. If the account's locked, we can provide them special information. We're not limited to what supplicants can do, how supplicants behave. We have kind of full control over that user experience. The key thing is, once that user has been successful, we can drive a certificate onto that device. So unlike the password, that certificate's immutable. So they can't mess with it. Right? If they go and tweak it or anything, they just break it, and then it's an invalid certificate and it just gets thrown out. But it's burned into that device. So when we actually go to look at a connection, the user's out of the picture. Right? The user's done. They've met their requirements at a web level in an interactive model. Once that device goes to connect on a daily basis, and this is a one-time process, right? So once a year, once every 6 months, once a semester, whatever your policy is on how long you want to burn that certificate in, user needs to be successful here once a year. This happens every time they connect. Right? So in the previous picture, that whole thing was happening on every single association. Now we've kind of decoupled it, burn the certificate in. Now when that device goes to associate, all we have to worry about is getting that certificate to the AP, getting it back to the Radius server. And then one interesting twist versus AD is that as we go back to check, and this process here is called OCSP, Online Certificate Status Protocol. At this point right here, we've got a really good idea that this is a valid user, right? Because we know the certificate was issued by someone we trust. We know it timestamp-wise is valid. Now all we really want to know is, has this user been kicked off? To do that, we reach back with OCSP. And in the old days, this would have been CRL, certificate revocation list, which was sort of a batch process. We're going to publish this once a day. We're going to publish this once a month. This is a real-time mechanism, and we can undo it. So, at 4:59, we can answer yes. At 5:01, we can answer no. And at 5:30, at 5:03, we can start answering yes again, based not only, based on all sorts of other criteria. But the cool thing is this is optional, right? We've established a layer of trust right here at the Radius server. We're only trying to establish a little bit more certainty. And so if you're if you're super secure environment, you may want to make this required. But if you're an education institution and or BYOD, where you're going to apply a lower policy anyway, that doesn't have internal access, if that times out, if that gets dropped, that's fine. And this is all UDP based, this is TCP based, right? So it's a little easier to troubleshoot and whatnot. So some of the knowns around EAP TLS, we know it works well. People have been using it on group policy on domains for years. It's the original 802.1 spec, right? Like everything from, it was on day one, it was the secure EAP protocol. Everything we've done since then has been weakening security in trying to make it easier to use. And so what we think is the industry, particularly the OS, is like everything we've done to make it more usable has compromised security. Those aren't two things we like balancing. Like we want to have our cake and eat it too. And so we want a different way to take care of those problems without weakening our security. So in a domain policy, worked great, put it in GPO, push it out, things worked. We know that it eliminates passwords from Wi-Fi, so we don't have to worry about the cache credentials and stuff. We can't eliminate every issue on Wi-Fi. If the user goes in and disables server cert validation, they're still going to connect to an evil twin. The good thing is they've made that choice. They've taken that action. We hate to see them do it, but there is a limit to how much we can protect them. But in that case, we've decoupled our exposure from their exposure. So they've, that user is, they might be subject to man in the middle, but they haven't compromised their credentials, which is really the gateway into the enterprise. As I touched on, it offers greater site survivability. Like, I got really tired of trying to explain to users, in huge distributed environments, like, no, yes, you want to deploy 2200 radius servers, so you have one on every site. No, you're not going to have fun doing that. Yes, you're going to have trouble troubleshooting UDP going over, going globally and so forth. And it's sort of like the eduroam example. And if we have time later, I want to touch on kind of a comparison with eduroam. The eduroam guys have done a great job, but it takes a lot of effort to run that environment because it's, it goes back to all those issues. It's time sensitive. It's UDP based. It's just kind of the nature of the beast with Peep. In TLS world, it can work exactly the same, but at the same time, you have opportunity if you wish to optimize that and rely more on OCSP as the back end. We know it uniquely identifies every device, or it should. If it's done properly, it uniquely identifies every device. So we can have Bob with 5 devices. We can still have a concept that those 5 devices are Bob, but we also know that that's Bob's iPad, that's Bob's IT-owned iPad, that's Bob's laptop, so forth. And we can control those at both levels. So we can say, let's kick Bob off or prevent Bob from ever getting on again. Or we can say, Bob's laptop seems to be misbehaving. Let's kick off that one device, but let's leave his other devices alone. And then it allows decentralized roaming. I touched on that a minute ago with eduroam. Eduroam's a very centralized model, and Peep really needs that model to work. With TLS, you have opportunity to decentralize it. And as you move into, centralized works great in education. When you start getting into enterprise, you got to figure out a way to decentralize it so you don't have to have a special purpose entity, running the centralization. So the challenges with TLS, like I touched on earlier, traditionally it's been setting up setting up the certificate infrastructure. You start on day 1 and you don't have any idea about certificates. On day 2, you've got a really bad headache, right? And somewhere along the line, you probably made a mistake, and the mistake's going to creep up and bite you later on, and all that sort of thing. And at the end of the day, once you get that certificate infrastructure up and running, it's like, woohoo, we're ready to turn users loose. And then someone's like, okay, how do I get it on my Android device? Like, oh, all right. So then we got to start getting certificates on the device. So we got to get them on there. And then, just like user-based policies creeped up and bit us with Peep, where we could never distinguish one user's device from another. And it really became that oh crud moment for enterprises when they realized that what they thought was their IT asset only Peep network was really a bunch of iPhones and so forth. And people's personal devices were suddenly on there because they knew how to type in their passwords and click accept on screens. With Peep, you couldn't differentiate there. TLS, if you do it with certificates, if you do it incorrectly, you can run in that exact same problem. So we see some products where their support for certificates is give us one certificate and we'll push it on every device. Like, okay, that just you gained encryption and you completely destroyed every other thing you wanted to do. And oh, by the way, just like a pre-shared key network, if you decide that certificate was compromised and you have to revoke it, you just kicked all your users off the network. The authorization to multiple privileges, so similar to devices, being able to get it differently. Mapping certificates to uses, so it's great if you have a single use case that you're envisioning for your certificates that keeps it simple. It becomes more complex if you're saying, okay, I want to, and today we're really talking about certificates within the Wi-Fi spectrum, within the Wi-Fi realm. But the beauty of it is it's a spec that carries all the way up the stack. Right? So once you have that certificate, you can use it for single or two-factor authentication on a website. You can use it for active sync. So instead of sending your password to Exchange all the time, you can send a certificate. Now we can say, oh, that device is allowed to get to Exchange, that one's not. They're both allowed to get on Wi-Fi. We can separate policies and say, depending on what hurdles you're willing to jump through, what things you met, and I'll get into that later with the workflow in the product, how we take care of that. And then managing lifecycle. There's always been this contention around if you issue, let's take a guest user, right? A person that's sitting on your OpenSSID today, every day they're getting the captive portal page. You move them into the TLS world, you certainly can give them a certificate that's good for one day. They just go through the same process every day. At the same time, you have this opportunity to give them a certificate that's good for a year, 2 years, 10 years, 100 years, whatever you want. And so it's really up to you. So traditionally, there's been this contention that said, well, if I give them a short life cycle, it's nice because if that device goes away, is lost, and so forth, I don't have to worry about it. But giving them a long life cycle is nice because they don't have to go through enrollment as often. Right? So if you take like a BYOD situation and say, okay, I'll let you provision for 1 year at a time. Once a year, I want you to accept my use policy, which we can enforce through TLS. We could never enforce that through Peep because there are ways around it. So I want you to accept my use policy once a year. I want to do a sanity check on your device once a year, or if you're in a university, once a semester, or whatever you want to do. So now we can do all those NAC type checks. We can make sure your machine's in a sane state without having to run an agent on it all the time. And but at the same time, if we gave that thing to you for a year, and next month you lose it, there was this huge risk for the enterprise because now you had this device hanging out with a certificate on it that was good for another 9, 10, 11 months. And so people had shortened their life cycle. So one of the things we've built in is just this automation around the life cycle. And so one of the examples of it is we know when they're using that certificate on the wireless network, or even when they're using it on active sync, because we're getting that callback with OCSP. And so we can keep track of that and say, well, great, I'm gonna give you a certificate that's good for a year, but if you go away for 14 days, it's off the network. So now I don't have to worry about, if I'm deprovisioning IT assets, I just lock them in a room for 14 days. They clean themselves up. I don't have to go manage them somewhere else. At the same time, 30 days later, all of a sudden that device jumps back on the network. In the old days with the ideas around revocation is once you revoked it, it was gone. Now we can make smart decisions. So we see an OCSP request come in for something that's been revoked, or that was revoked because we didn't see it for 30 days or 14 days, 30 days, whatever it is. Now we can make a smart decision, right? We can say, okay, you're back, welcome back, great. We could email them and say, sorry, I refused your authentication, but I'm not quite sure it's you. Click here to reactivate your certificate because you're able to check your email or your SMS. We can fire off an email to the administrator to say, hey, one of your IT assets suddenly came back online. Do you want to accept, if it was a video camera, for example, say you put a certificate on a video camera, you threw it in the back room for 6 months, and then you went and plugged it in, and all of a sudden, you get a text saying, oh, hey, camera 1 is back online. Is that okay? Like, heck yeah, I don't want to get back on the camera's web interface and upload a certificate again. Just, yeah, accept. And now that device is back. In the meantime, you weren't exposed. So our legacy is in onboarding, and we still do onboarding, but we see what we're doing as being much bigger than onboarding, and we call it device enablement. And so in onboarding, it was all about providing a generic configuration into the device that was sort of decoupled from their credentials, right? So we could take one configuration that was good for everybody, put it on the device, at runtime marry it up with some credentials, and that became their authentication attempt on the wireless network. That hit the Radius server. The Radius server had to pretend it had never seen that device before, even though it probably got authentication from it 5 minutes ago. And it had to restart all of its calculations. It had a very narrow window to figure out what policy it should apply to it. And it really had limited information. It had username, password, maybe MAC address. But, you know, and in that model, you have to, it emphasizes kind of a smart radius server. You got to have a really powerful radius server. It's got to do a lot of calculations really fast. You got to add more and more policy. And that was something we just saw as being sort of like a wireless controller. It was something that was dictated by kind of the standards and the vendors. It wasn't something that really helped your network work the way you wanted it to. So we differentiate device enablement as really doing a smarter job of the enrollment. So instead of just giving everybody one-size-fits-all config, pulling in their username and password and using that for policy, we're really making those decisions up front during that enrollment process. And so during that enrollment process, you know, we say, oh, you're an employee, great, you know, let's authenticate you against AD. Oh wait, I just bought a company, I have 2 AD systems. Okay, are you in the New York office or are you in the California office? Okay, if you're in New York, I'm gonna authenticate you there, California there. You know, is this an IT asset or is this a personal device? You know, if you're an IT administrator, maybe you have click through and you can, you know, provision the device as a you know, super user on the network, whereas you certainly don't want those privileges for other people. And in doing so, then we derive the certificate, and the certificate has a policy tied to it. And that policy is what's smart about it. It's not the dumb policy where I referred earlier, like you can run certificates in the same old model of just saying, give me your username and password and I'll fire you a certificate. But we've really gathered nothing more than what we have available with Peep. But what we want to do is we want to be able to tie all that information together and be able to say, okay, you know, you've met these criteria and therefore I'm gonna allow you these services. Tomorrow, if I decide I don't want you having email, I'll kick you off email, but I'll still let you on Wi-Fi. But your other device, it's only ever going to get on Wi-Fi. And so in this world, it really becomes an emphasis more on the enrollment side of things. And there's sort of this tight coupling between enrollment and the certificate authority. So going back to automated device enablement being secure onboarding plus certificate management, when you tie those two together, you're able to get this tight circle that feeds off each other.